So for part B, what we need is this 2.50 grams of aluminum. That's the limiting reactant. We're going to see how much of the carbon did the limiting reactant use up. Because once we know how much is used, we can subtract to get how much was left over. 2.50 grams of aluminum. Now we're going to go grams of aluminum into moles of aluminum. We're going to go moles of aluminum into moles of carbon. And then we're going to go moles of carbon into grams of carbon. 26.98 grams of aluminum in 1 mole. And then this is 4 to 3. And then we're going to do the grams of carbon is from the periodic chart or from the problem. Notice again, we still just need 3 sig figs. All right, so we've got 0.835 grams of carbon. That's how much was used. We want to go back and double check how much was initially did we have, and it's going to be that 2.5 grams of carbon. That's the total amount that we had. So 2.50 grams minus the 0.835 grams of carbon. And that's going to give us 1.67 grams of carbon. That's how much is left. Notice that it's to the 100th place. And the 0.835 was what was used up in the reaction. This place, the other one is the 100th place, so that's why it only goes to the 100th place. And we're going to start with labeling underneath. We've got the 5.50 grams, and look, we've got the 3.48 grams of aluminum oxide. So those, there's nothing for the oxygen, so whenever that happens, that means that the oxygen is in excess. So we don't have to worry about them. All we have to do is one train track for this one. We're going to take the 5.50 grams and turn it into grams of aluminum oxide. 5.50 grams of aluminum. Okay, again, grams on bottom. Oh, yes, and we're going to figure out how many grams of aluminum oxide that we're trying to figure out. So grams of aluminum into moles of aluminum. And we have moles of aluminum into moles of aluminum oxide. And then we're going to put the moles of aluminum oxide on the bottom. And that's going to go into grams of aluminum oxide. This is from the periodic chart, 26.98 in 1 mole. Look at your coefficients. Okay, so it's not balanced, so we can't actually put any coefficients in until it's for sure balanced. So I got 2 and 3. I got that even odd, so I need to fix that. Oh, that'll fix it, and then that gives me 4 aluminums. So now I know it's 4 to 2, or I could have written 2 to 1. It's fine, or I could have said that the 2 canceled into the 4, however you want to think of it. And then we've got our molar mass, 101.96. It was in the problem, and 1 mole equals, okay, 10.4 grams of aluminum oxide. Notice I just need 3 sig figs because of the 5.50 grams of aluminum. Notice that this is the theoretical yield. Notice that the problem is asking for 2 kinds of yields, a theoretical yield and a percent yield. The theoretical one is the calculating one, the percent is the one with the percent. So the theoretical yield should be the bigger number. It should be the one on bottom. The 3.48 is what the student actually produced. So 3.48 divided by 10.4 grams gives us, oh yeah, don't forget times the 100%. 33 I got 33.5 on this one. So kind of a low percent yield, but it is what it is.